Hi, everyone. Welcome to Science. This was our pH lab day, and this was on Tuesday, October the 19th. The students were testing different substances using this red cabbage juice. And I'll just go ahead and read this paragraph to you. It says, in this lab, you're going to use the juice from red cabbage as a pH indicator to test common household liquids and determine their pH levels. The students then mixed cabbage juice with the liquids, and they noticed a color change produced by a pigment called flavin. The chart below was a reference chart to help them determine what the pH was. So the question we were investigating in this activity was, how do we determine pH with red cabbage juice? The students then made their hypothesis predicting what they thought the different substances were going to be. Were they going to be acidic, neutral, or basic? And then the different substances they tested were over here on the left: hand sanitizer, all-purpose cleaner, lemon soda, white vinegar, baking soda, ammonia, and dish soap. If you missed this lab, why don't you go ahead and pause the video at this time and make your prediction. What do you think these substances are? All right, I'm going to jump ahead here a little bit. The students then tested. Again, we're using our safe protocol of no food, no gum, no drinks, wearing goggles. And this is what the students found. They found hand sanitizer to be an acid, all-purpose cleaner to be a base, lemon soda like Sprite is an acid, white vinegar an acid, baking soda a base, ammonia a base, and dish soap was an acid or a base. If we think about soap, it should be a base, but a lot of times they use citrus scent in there, and that'll sometimes skew our results a little bit. But technically speaking, dish soap should be a base. So go and see how you did in your prediction and how many you got correct. I'd like you to pause again here at this point and complete this chart. We've been talking about acids and bases for a little bit. See if you're able to complete this chart looking at some different characteristics of these substances. Then there's a little challenge at the end and why we shouldn't taste or touch things. So again, pause this video for a second and go and see what you can complete of this chart by yourself. Welcome back. Here's what I have written down for acids. They burn, they taste sour, they react with bases and metals and carbonates, they produce hydrogen ions, they turn litmus red. Examples are things like vinegar and lemons, and they're 0 to 6 on the pH scale. The opposite of that are bases. Bases feel slippery, they taste bitter, they react with acids, they produce hydroxide ions in solution, they turn litmus paper blue. Common examples are soap and baking soda, and their pH range is 8 to 14. Remember, 7 is neutral. If we're looking at these things, KBr is a neutral substance. I don't see a hydroxide at the end or a hydrogen in the front. It's actually a salt. Lithium hydroxide, I see that OH at the end. That's a base. Hydrogen and some sulfur together is sulfuric acid. The next one, we see a hydrogen there at the front. That is another acid. CaCl2 is a neutral substance, another salt. And the last one, we see those hydroxides hanging out at the end. That's another base. Important in science that we're not tasting or touching acids and bases for safety. The ones we were using today were pretty mild and not real strong acids or bases, but they can really harm you. So make sure we're always using safety as our number one priority when we're in the science lab. Students in class and listened to some fabulous pH songs and played some review games. Of course, there's a long weekend this weekend. We're off Wednesday, Thursday, Friday, Saturday, and Sunday, and we'll resume on Monday when we talk about neutralization. Please make sure all your homework assignments are completed as well. That should be for chemistry assignments 7 through 12. And if you have any questions, please reach out. Have a great weekend. We'll see you back on Monday.